The graph of a quadratic equation is a U-shaped curve called a parabola. When the leading coefficient is greater than 0, the parabola opens upward. When it is less than 0, the parabola opens downwards. The vertical line that divides the parabola into two equal halves and passes through its center is called the axis of symmetry. The turning point of a parabola is known as the vertex. The vertex always lies on the axis of symmetry. If the parabola opens upward, the vertex is its minimum point. If it opens downward, the vertex is its maximum point. The point where the parabola intersects the y-axis is called the y-intercept. It occurs when x equals 0. The points where the parabola intersects the x-axis are its x-intercepts or roots. They occur when y equals 0. Is to determine whether the parabola opens upward or downward. For a quadratic function in standard form, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. For our function, a is 1, which is greater than 0, so the parabola opens upward. Next, find the axis of symmetry, which is a vertical line that divides the parabola into two equal halves. The formula for the axis of symmetry is x equals negative b over 2a. For our function, a is 1. b is negative 4. Substitute these values into the formula. This simplifies to 2, right? Therefore, the axis of symmetry is the vertical line x equals 2. Next, find the vertex. The vertex lies on the axis of symmetry. So, its x-coordinate is the same as the axis of symmetry. To find its y-coordinate, substitute its x-coordinate back into the original function. This simplifies to negative 9. Therefore, the vertex is the point 2, negative 9. Next, find the y-intercept. The y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to negative 5. Therefore, the y-intercept is the point 0, negative 5. Next, find the x-intercepts. The x-intercepts occur when y equals 0. So, set y to 0 and solve for x. Let's use the factoring method. We need to find two numbers that multiply to give negative 5 and add up to negative 4. We know that 1 times 5 equals 5. But if we make 5 negative, they multiply to negative 5 and also add up to negative 4, right? Therefore, when we factor this quadratic equation, it becomes x plus 1 times x minus 5. Next, set each factor equal to 0 and solve for x. Solving the first equation, we find that x equals negative 1. Solving the second equation, we find that x equals 5. Therefore, the x-intercepts are the points negative 1, 0 and 5, 0. By the way, if you want to master how to find the axis of symmetry, the vertex, and the x and y intercepts of quadratic functions, please check the links in the description. There are videos for each topic with plenty of examples. Now that we have almost all the points we need, the next step is to plot them on the graph. The axis of symmetry is the vertical line x equals 2. The vertex is the point 2, negative 9. The y-intercept is the point 0, negative 5. The x-intercepts are the points negative 1, 0 and 5, 0. Now we add one final point, which is symmetric to the y-intercept across the axis of symmetry. Notice that the y-intercept is 2 units to the left of the axis of symmetry. And remember, the axis of symmetry divides the parabola into two equal halves. So, a point 2 units to the right of the axis of symmetry is also on the parabola. This point is 4, negative 5, right? Finally, connect these 5 points to plot a parabola opening upward. In this example, we were able to easily factor the quadratic equation when finding the x-intercepts, right? However, this is not always the case. Sometimes, factoring can be difficult or time-consuming. Even if you use the quadratic formula, the discriminant might not be a perfect square or could be negative. So, what should we do in such cases? Let's see that with this example. First, determine whether the parabola opens upward or downward. A is negative 1, which is less than 0, so the parabola opens downward. Next, find the axis of symmetry using x equals negative b over 2a. A is negative 1. B is 6. Substituting these values into the formula, we find that x equals 3, right? Next, find the vertex. Its x-coordinate is the same as the axis of symmetry. To find its y-coordinate, substitute 3 for x into the original function. Simplifying this, we find that y equals 6. Therefore, the vertex is the point 3, 6. Next, find the y-intercept. Remember, the y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to -3, right? Therefore, the y-intercept is the point 0, -3. By the way, the y-intercept always equals the constant term. Now, if you try to find the x-intercepts, you will find that the quadratic is difficult to factor. Even if you use the quadratic formula, the discriminant is not a perfect square, so you may need a calculator. In such cases, instead of finding the x-intercepts, we can use other points. Let's first plot the points we already have, and we will come back to that. The axis of symmetry is the vertical line x equals 3. The vertex is the point 3, 6. The y-intercept is the point 0, -3. Also, locate a point symmetric to the y-intercept across the axis of symmetry. The y-intercept is 3 units to the left of the axis of symmetry, right? So, a point 3 units to the right of the axis of symmetry, which is 6, -3, is also on the parabola. Now, to find other points, take an x value that is closer to the axis of symmetry and determine its corresponding y value. Let's take x equals 1. You can also take 2, which is even closer to the axis of symmetry, but it is easier to work with a smaller number, which is why I preferred 1. To find its corresponding y value, substitute 1 for x into the original function. Simplifying this, we find that y equals 2, right? So, we have the point 1, 2. Plot this point on the graph. Now, just as we located a point symmetric to the y-intercept across the axis of symmetry, we also locate a point symmetric to this point across the axis of symmetry. This point is 2 units to the left of the axis of symmetry, right? So, a point 2 units to the right of the axis of symmetry, which is 5, 2, is also on the parabola. Now, connect these 5 points to plot a parabola opening downward. Notice that in both this example and the previous one, the parabolas cross the x-axis twice. First step is to determine whether the parabola opens upward or downward. For a quadratic function in standard form, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. In our function, a is 1, which is greater than 0, so the parabola opens upward. When the parabola opens upward, the quadratic function has a minimum point, which is the vertex of the parabola. So, our next step is to find the vertex. First, find its x-coordinate using the formula x equals -b over 2a. In our function, a is 1, b is -10. Substitute these values into the formula. Simplifying this, we find that x equals 5, right? So, the x-coordinate of the vertex is 5. Now to find its y-coordinate, substitute its x-coordinate back into the original function. Simplifying this, we find that y equals -4. So, the y-coordinate of the vertex is -4. The minimum value of a quadratic function is the y-coordinate of the vertex, which is -4 in this case. This occurs when x equals 5 is given in vertex form. Also in this case, first, determine whether the parabola opens upward or downward based on the sign of a. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. In our example, a is 3, which is greater than 0, so the parabola opens upward. Therefore, the quadratic function has a minimum point, which is the vertex. For a quadratic function in vertex form, the vertex is the point h, k. So you just need to identify the values of h and k from the given function, but be careful about the signs. Notice that we have a negative h inside the parentheses, but the h in the vertex is positive. So, for h, we take the opposite of the number inside the parentheses. For k, both in the function and in the vertex, the signs are the same, so we take it as it is. In our function, The number inside the parentheses is -2, and h is the opposite of it, so it is +2. K is the constant term as it is, so it is equal to 7. So, the vertex is the point 2, 7. The minimum value of the quadratic function is the y-coordinate of the vertex, which is 7. This occurs when x equals 2. Now, try this one. A is -1, which is less than 0, so the parabola opens downward. Therefore, the quadratic function has a maximum point, which is the vertex. To find the vertex, identify the values of h and k. H is the opposite of the number inside the parentheses, so it becomes -4, right? K is the constant term, so it is -9, right? So, the vertex is the point -4, -9. The maximum value of the quadratic function is the y-coordinate of the vertex, which is -9. This occurs when x equals -4.